Good morning, class. This is group one, and we're going to solve question 4 on the homework. You can pause the video and read the question yourself. Thank you very much. First thing I want to do is record all the mechanical properties for each material in this problem. So here's the information for the steel, and here's the information for the brass. And the sleeve is made of brass, the bolt is made of steel. Then we want to determine the areas. It's just pi r squared. We all know that one. One thing that might be a little tricky is that the sleeve is hollow, so we want to subtract the internal area, which is described by the inner diameter, or inner radius, but in this case it's diameter divided by 2. And we're going to find these in terms of these areas in terms of meters, so that's why our millimeters were divided by 1,000, and there we go. And then we want to create a free body diagram and use our equations of equilibrium to find an equation that relates P to NB and NS. And then once we do that, we can use a compatibility equation because the displacement of the bolt is equal to the displacement of the sleeve. Here's the actual formula here's the displacement formula. So what we'll do is we'll set these equal to each other and use the properties for each material. So here is the normal force of the bolt, which we don't know yet. And here's the normal force of the sleeve, which we don't know yet. But what we do know is our areas and elastic moduli. I think that's the plural of modulus. And length, like I said earlier, the displacement is going to be the same throughout the load application, so the length is going to be equal throughout, so we can just cancel those out. And then we can solve for NB or NS. We decided to solve for NB, which is 2/3 NS. Moving forward, we want to consider the scenario where the bolt fails first. So what we're going to do is we're just going to use our stress equation that we learned in 240, which is N over A, or normal force over area, because we were actually given our yield stress, if you remember from the first slide. So a little bit of algebra here, multiply our yield stress by the area, and we're given a force. So our normal force of the bolt is going to be 50,265.5 newtons. And then there's more. We were given a relationship, or we found a relationship between NB and NS. So we also have NS. And then we have a relationship between P and NS and NB. So then we have P. So if the bolt is going to fail, it will fail. The smallest force that's going to cause the bolt to fail is 125,663.7 newtons. Now we're going to do the same thing for the bronze sleeve, but we're obviously going to use the yield stress of the bronze, or was it brass? Either way, we're going to multiply the yield stress by the area, and we'll get a force. So the normal force of the sleeve is going to be 122,522.11 newtons. And then we're going to use our NB equals 2/3 NS equation again to find NB. Now we have NS, now we have and NB. So we're going to plug those into P equals NS plus NB, and we'll get 204,203.52 newtons. And then it's pretty obvious to see that the bolt is going to fail first. So the force that causes failure to the bolt is our maximum force for P. So final answer is 125,663.7 newtons.